So today we're going to take a little diversion from learning new physics and learn a technique called the linearization of graphs. So up until this point we've done lots of graphs and we found the graph type using programs, but I'd like to show you guys a technique for figuring out graph constants of nonlinear graphs. Okay, so let's say we had a graph of kinetic energy versus speed. We collected some data at different speeds and measured the kinetic energy of the object. We then plotted out and we see that we get a squared relationship. We know the equation for a squared relationship is y equals ax squared. But how do we actually find this graph constant? We can't just pick 2 points and find the slope because the slope is constantly changing. So the way we attack this is what's called the linearization of your graph. So the goal of this is to take the original data, do something to either the x or y axis that will allow the graph to turn from whatever type it started into a linear graph. And so for a squared graph, you're just going to take your x values and square them all. So we square 0, 3, 5, 7, 9, and 11. And we get 0, 9, 25, 49, 81, and 121. When we then plot the same kinetic energies versus the square of the speed, we get a linear graph, which we can now pick 2 points on the graph and find the slope. The slope will be the same as the graph constant that we get for our regular squared graph. And in this case, the slope turns out to be 2.5. All right, so the whole purpose again is to turn your original graph that's not linear into a linear or proportional graph and then quickly find the slope of that linear graph so that you can figure out the graph constant. And even in my program, where you just hit a button and it gives you the graph constant, behind the scenes it is doing all of this work. So this is an important technique to understand, the linearization of data. Okay, if you had a square root graph and you wanted to linearize it, you could take each of your x values and this time take the square root of those x values. Okay, so you have your graph looking like this. We take the square root of each of our x's, we then plot that, and we get a nice linear graph. Again, the slope will be the same as the a value of this graph. So today I'd like you to practice this skill, and we're not going to use my graphing program. I'd like you to practice it by hand so you get a real deep awareness of exactly what it is you're doing and how it is giving us our graph constant. So you're going to have 2 different data sets. And what you're going to do is you're going to start by just plotting out your original data. So in the first case, you're going to plot radius and volume. You're going to look at how the radius of a sphere affects the volume of the sphere. And again, don't use a graphing program. Use your skills where you're going to put radius on the bottom, volume on the y, look at your highest numbers, and scale your axes accordingly. Once you plot out the graph, you then want to see what kind of relationship it is and adjust things accordingly. So for the volume to radius, we know that it should come out to be a cubed graph. So what you're going to do is after you plot your original graph, you're going to cube all of your radii and fill that data into this column. Then take that data, and this time you're going to put radius to the cube versus volume. And if all went according to plan, you should get a linear graph when you cube all of your x values. Again, you're using the radius as your x. Okay, then you're going to try it with volume and pressure. So you're going to graph it out originally. You're going to have actually pressure here, volume here. And again, scale it by hand, start at 0, work your way up, work your way over, and plot out your data. When you plot this out, I hope you get an inverse graph. So what you're going to do to straighten it out is you are going to create a new column where you do the inverse of volume. Create an axis, plot it out, and we should, in this case, get another linear graph, and that again will be the graph constant that we would have gotten for the original graph. So I just want you to again practice the idea of how to turn a nonlinear graph linear, and then using the linear graph to determine your graph constant. All right, you should have a sheet. You can print this out off of the Google Classroom and do all of your work on this, and then just attach a picture of your work to get credit for today.